Hi and welcome. In this video, I will discuss subnetting with regards to Internet Protocol version 4 networks or IPv4 networks. And I will start from basics and then move on to advanced concepts in subnetting. And at the end of this video, I will also discuss an operational example of subnetting a network. If you like my effort, then do subscribe my channel for similar videos. Now an IPv4 address comprises of 32 bits, and these 32 bits are divided into 4 octets, and each octet contains 8 bits. So once you see an IPv4 address, then you do not see it in a binary value or in a binary version. Rather, you see it in a decimal form, where each octet is represented by a decimal number, and this decimal number may range from 0 to 255 in each octet, and each decimal number is separated by a dot notation, where this dot notation depicts the separation between each octet. So each value or each decimal value in an octet ranges from 0 to 255. So actually there are 8 bits in each octet, and the value of these bits can be 0 or these can be 1. So if all the values in an octet are 1, then this value will become 255, and if all the values in an octet is 0, then this octet value, decimal value, will become 0. And if value ranges between 0 and 255, for example 3, then it means that certain bits are 0 and certain bits are 1. And in this table I have performed a certain calculation of an IPv4 address. So in the top row you can see that this is decimal values which are separated by a dot notation, and D depicts a decimal value. And this decimal value is actually the combination of the binary value in the second row, and these binary value are calculated based upon this formula of bits calculation, where in each octet the bit on the right side has a least value, or it is a least significant bit, and the bit on the left side in each octet is the most significant bit and has a larger value. And in the last row you can see the values or the decimal values which all these bits are making. So once you perform this calculation, you get a decimal value in which this IP address is reflected. Now once we talk about classful IPv4 addressing, so this classful IPv4 address has 5 classes from 0 to E, that is class A, class B, class C, and class D, and then class E. So in class A, the decimal value in first octet ranges from 1 to 126. So if you see an IP address with a value in first octet between 1 and 126, then it means that it belongs to class A address, and this class A address is normally used by internet service provider. So in this class A IP address, the first octet is used for network addressing, and then remaining 3 octets are used for endpoint points address or host address in that particular network. So for example, in this table, the first octet reflect the network address, and the last 3 octets reflect the host address in a particular network. For example, if in class A addresses there are around 126 networks, then in each network there are around multiple hosts. So in class A IP addressing, in the first octet, the first bit in the first octet is always 0, and then the rest 7 bits can be 0 or 1. So the decimal value cannot be 0 or cannot be 1. It means that the all 8 bits in the first octet cannot be 0 or cannot be all 1, because if these bits are all 1, then it means that they are making a value of 127, and this 127 network is used for network testing. So in class A IP address, there are around 126 networks, and then in each of these 126 networks there are around 16 million hosts, and this is the calculation of the host. For example, in the host bits are around 24, that is each 8 bit of each octet, because the last 3 octets are used for host addressing. So these octets are making of 24 bits, and these 24 bits makes up 16 million IPs. So first IP in a particular network, that is all zeros of host bits, will be used for network address, and then all ones will be used for broadcast address, that is the last IP of that network. So if the host bits are all ones, then this would be the broadcast address of that network, and this broadcast address is used to broadcast traffic in a particular network, which will be received by all the hosts in that particular network. So this class B IP address is used by universities, and this in this class B IP address, if you see an IP address with the value in the first octet between 128 to 191, then it means that this IP address belongs to class B. And in class B IP address, the first 2 octets are used for network addresses, and the last 2 octets are used for host IP address in each of that networks. So if you see this table, then the first 2 octets are used for network addresses. So if you see a value in the first 2 octets, it would be the network value, and the last 2 octets are used for host in a single particular network. So in class B IP address, in first octet, the first 2 bits are 1 and 0, that is the static value, and rest 6 values in first octet, that is the binary values, can be 0 or 1. So in class B IP addressing, there are around 16,000 networks, and in each of these 16,000 networks there are around 65,000 hosts. So this is the calculation of the networks and the host. Since the first 2 bits in the first octet are static, therefore we have 6 bits in the first octet and 8 bits in the second octet for network addressing, making up a value of 16 1000, and then for host we have last two octets, that is the 16 bits, and we have to subtract two IPs from host portion, because first IP will be used for broadcasting, for network address, and last IP will be used for broadcasting in that network. Then in class C IP address is used by the companies that are smaller, and if you see a value in an IP address in the first octet that ranges between 192 to 223, then it means that it belongs to class C IP address. And in class C IP address, the first three octets are used for network addressing, and the last octet is used for host addresses. So first three octets are used here in this table for network address. So if you see a value in the first three octets, it represents the network address of that particular IP. And if you see the value in the last octet in class C IP address, then it would be the IP address of an endpoint or a host in that particular network. So in class C IP address, in the first octet, the first three bits are the most significant bits are 1, 1, and 0. And then the remaining 5 bits in the first octet can be 1 or can be 0. So there are around 2 million networks in class C addressing, and around 254 hosts. That is, only the last octet is used for host addressing, therefore hosts are very less. So this is the calculation. So the network addresses are around 21 bits, since the first 3 bits in the first octet are static, therefore we are using the 5 bits in the first octet and 8 bits in the second octet, and then the 8 bits in the third octet for network addressing. And in the host portion we are using only the last octet, that is the 8 bits, but we have to subtract 2 IPs, because first IP would be the network address of that particular network, and then the last IP would be the broadcast address of that network. Then there are the class D addressing, which is used for multicast, where you want to send traffic to particular set of networks. So this is to multicast, for example, web casting, webinar to multiple networks. So if you see a value in the first octet which ranges from 224 to 239, then this octet this IP address is of class D. And in class D IP addressing, the first 4 bits in the first octet are static, that is 1, 1, 1, and 0. And then the class E IP addressing is used for future purposes or for experimental purposes. And if you see a value in the first octet ranges from 240 to 255, then it belongs to class E IP addressing. And in class E IP addressing, the first 4 bits are in the first octet are static, that is all ones. Now we come over to the classless IP addressing. First of all, I will discuss the private IP addressing. So this private IP addressing is defined through RFC 1918, and basically all the IPs which are not private IPs are public IPs. So for example, your company is assigned or has leased a public IP from internet service provider, and then since you have only single IP or single network, so you want to further use the IP addressing, but you do not have other IP public IPs. Therefore we created this private IP addressing, and this private IP addressing is performed in the internal networks isolated from the internet. So this private IP addressing cannot be used to communicate over the network. So if a computer which is installed in your local network wants to communicate to the over the internet, then we perform the network address translation or NAT, where this private IP address is translated to a public IP address on your router, and then the traffic is communicated with the internet. Now this private IP address is only used in your internal networks, and this class A IP address of 10 network, this is a single network, and this single network has 16 million hosts. So you can use once you see an IP address with this 10 decimal value in the first octet, then it means that this is a private IP address, this is not a public IP address. So this the first octet is used for network address, that is only the one network of 10 is used in as a private IP address. So there is only one network and there are around 16 million hosts, and this is the calculation of the host, that is the remaining 3 octets. Then 172.16, and this is a class B IP address. So 172.16 to 172.31, if you see a value in the first 2 octets ranges between these values, then it means that it is a private address, it is not a public address. So first 2 octets are used for network addressing and last 2 octets are used for host addresses. So there are around 16 networks, that is 172.16, 172.17, 172.18 till 31. So there are 16 networks in this private IP address class, and there are 65,000 hosts in each network, in each of these 16 networks. So then there is a class C IP address, which is also a public private IP address, that is 192.168. So this is only a single network. This is not the case like the earlier class B IP address of 172.16 to 31, where we are using we have 16 networks. This is only a single network like 10 network of class A. So in this we have 65 this is not the 65 because first 3 octets are used for the network addressing and last octet is used for host addressing. So we have only 256 IPs available at host, and we have single network of 192.168, and then we have around 256 more networks, because since 192 is the class C IP address, so 3 octets are used for network addressing, and in third octet we have the liberty to use 256 addresses as network addresses. So I stand corrected that it is not a single network address. We have 256 networks in this class C IP address of private, which is a private IP address, which starts from 192.168. So it can be 192.168.0, then 192.168.1 till 192.168 maybe 255. So there are 256 addresses which we can use as network address, and then the last octet is used for host addressing. So we have 256 hosts as well, but since we are eliminating the 2 IPs from the host portion, that is first IP would be used for network address of that particular private IP network, and the last IP would be used for broadcast in that network. So we have around 256 networks in this class of in this private IP addressing, and we have 254 hosts in each of these 256 networks. Now there is one more concept of automatic private IP addressing, and this is used basically once the DHCP, that is the dynamic host configuration protocol, is not available. So once an endpoint is not assigned an IP address by its DHCP server, then it resumes or assign itself an IP address out of this automatic private IP addressing. And this automatic private IP addressing, if you see an IP address with the first two octets with 169.254, then it means that this is the automatic private IP addressing, and DHCP is not providing the IP address to the endpoint, and endpoint itself is getting the IP address. So this is a class B IP address, so first two octets is used for network address. So this is a single network which has around 65,000 hosts. Now coming over to the subnetting or classless inter-domain routing or CIDR, or it is also sometimes referred to as variable length subnet mask. Now at the start of this video we have discussed the classful IP addressing, but sometimes we need to subdivide our network into multiple networks. So this subnetting or the classless inter-domain routing provides us a mechanism to subdivide our network. For example, we are provided with an public IP address, then we may any IP address, we may subdivide this network into multiple networks as per our requirement. So why we do this? We do it for the security purposes, because then the broadcast traffic in each of these divided subnet would be isolated from other subnets, and also for performance purposes, because all the endpoints won't be getting the traffic from other endpoints, so they would be getting the traffic from only the intended endpoints which are in the same subnets. And also for management purposes, because we subnet particular departments in a single subnet, and then for example accounting department would be in single subnet, and then maybe the HR department would be in another subnet. And also it saves IP to get wasted. For example, we have only two hosts, so we do not want to waste an entire network of 256 hosts, so we divide this network into multiple subnets. Now this is an example of class C IP address, which is also a private IP address. So this is a class C IP address, that is, we are using the first 3 octets or 24 bits for the network portion. So this 192.168.2 is the network address, and first 3 octets are network addressing, and the last octet is used for host addressing. And this is a single network which has around 254 hosts. So we want to divide this network of 250 maybe 256 host addresses into 4 subnets. So we want to divide this subnet, which has 256 host IPs, into 4 subnets, and then it means that each subnet would contain 64 IPs. So Since we want to do this, therefore we need 2 bits from the host portion, and these 2 bits would be the most significant bits, or the bits on the left side of last octet, which was previously used for host addressing in class C IP address. Now we want to borrow these 2 most significant bit from the left side of that fourth octet into the network addresses. So because these 2 bits would create addressing for 4 subnets, that is 0 0, then 0 1, then 1 0 and 1 1. So the first now this would make the network address to increase from 24 to 26, since we have borrowed 2 bits from the host portion. So this first subnet would be the same one, that is with the 0, and we have borrowed 2 bits from the network for network from the host portion. So host portion is left with the 6 bits in the third octet. So subnet masks, I have not discussed it earlier, but actually in subnet masks all the network bits are 1 and all the host bits are 0. So once we will perform this calculation, it would make a decimal value of 255, that is all bits in the first octet are 1, and then in the second octet same value, third octet same value, in the fourth octet we are using only the 2 bits on the which are the most significant bits, or the bits on the left side of this octet. So the leftmost significant bits, once these 2 bits are also 1, then it would make a value of 192, and rest 6 bits which are part of host portion would be 0. So we would create 4 subnets, and in each subnet then the number of hosts would be decreased to 62. So in original class C IP address, the number of network was only single, that is one network, and this network had 256 IPs or 254 hosts. But once we divided this class C IP network into 4 subnets, then the number of hosts were also divided between each of these 4 subnets. So now each subnet contains 64 IPs or 62 hosts, because first IP would be used in each subnet for its subnet address, and the last IP in each subnet would be used for its broadcast address in that subnet. So these are the 4 subnets, that is the 0 subnet, then the 64 IPs would be used by this 0 subnet, and then the till 63, and 63 would be the broadcast address, and then the 64 would be the next subnet, and then likewise 128 would be the next subnet, and 192 would be the next subnet. So in first subnet, the subnet address would be the 0, that is 192.168.2.0, and its broadcast address would be the last IP in that subnet, that is the last IP, that is the IP before the next subnet, that is the 63. So 63 would be its broadcast address, and 64 would be the address of next subnet. So 63 would be the broadcast address, and if you send a traffic on 192.168.2.1.63, then this traffic would be received by all the hosts in that subnet, and these hosts can range from 1 to 62. So the IPs from 192.168.2.1 to 192.168.2.62 can be assigned to any host in this subnet. Now likewise in second subnet, this would start from 64. So the subnet address would be the 64, that is 192.168.2.64, and broadcast address would be the last IP in that subnet, that is 127, and 128 would be the next subnet. And the IP which can be assigned to the endpoints would range from 65 to 126. Likewise in third subnet, which would start from 128, that would be its subnet address, and its broadcast address would be the last IP, that is 191, and the IP which can be assigned to endpoints in that subnet would range from 129 to 190. And in the fourth subnet, that is the last subnet, its subnet address would be the 192, that is the first address, and the last address would be its broadcast address, and IPs would be from 193 to 254. Now this is an operational example how you perform subnetting in your networks. So this is a class C IP address of 192.168.2. So this was now this oval shape depicts the 256 host in this subnet. So the network address of this network would be 192.168.2.0, and the broadcast address would be 192.168.2.255, and IP or the IPs that can be assigned to the endpoints would range from 1 to 254. But we have a problem. We want to divide this subnet into two portions of 128 IPs. So what we would do that we need two networks, so we have to borrow one most significant bit from the last octet, that is the most significant bit of fourth octet which belongs to host IPs. So then the remaining 7 bits would be used for host addressing, and this most significant bit or the left most bit would become part of subnet or the subnetting. So once this value of this bit would be 0, then this would depict the first subnet of 128 IPs, and once the value of this most significant bit in the fourth octet would be 1, then it would depict the second subnet of 128 IPs. So earlier this class C IP address had 256 IPs. Now we are dividing this network into two subnets of 128 IPs each. So this would be the first address of this subnet, that is 192.168.2.0. Now rest where the question mark is, or sign of this question mark is displayed, are the 7 bits of host portion. So we have borrowed the most significant bit of fourth octet for our subnetting purposes, and rest 7 bits are part of host portion. These bits can range from 0 to 1. And second subnet would likewise, the first bit would be part of subnet, that is 1, and the remaining 7 bits can be used for the host in this one subnet. So this value would be static, that is 0 and 1. So in first subnet, this the value in the last octet would always be 0. The most significant bit in last octet, that is fourth octet, would be always 0. And in the second subnet, the most significant bit in the fourth octet would always be 1. So this is the network address of the first subnet, and this is the network address of second subnet. So first subnet would start from 0 and second subnet would start from 128. And 0 would be the network address, 127 would be the broadcast address, and IPs would range from 1 to 126, which can be used by the endpoints in that subnet. And in second subnet, the network address would be 128, broadcast address would be 255, and IP which can be assigned to endpoints would range from 129 to 254. Now we have another problem. Now we do not want to waste IPs in the second subnet, and we want to further divide this second subnet into 4 subnets, and each subnet has to create 16 IPs. So we want to use half of the second subnet, and remaining half we want to spare it for future purposes. And in first half of this 128 subnet, we want to create further 4 subnets of 16 IPs each. So in 128 subnet, we want to utilize it till 192, that is the half of this 128 subnet, since it goes till 255, and the values from 192 to 255 we want to spare it for future purposes, and we want to create 4 more subnets in 128 till 192, that is 64 IPs, and 64 IPs would be spare for future purposes. So for example, we need 10 hosts in each of these additional 4 subnets, and the subnets should be between 128 to 191, and therefore we require minimum 4 bits from host portion. So earlier this 128 subnet was using only the most significant bit, that is only the 1 bit from the left side, from leftmost side in the host portion. Now it want to use 3 more bit values for subnetting purposes. So this would become /28. So we are using the 4 values, and the first 2 values would remain 1 and 0, and remaining 2 bits would be range from 0 to 1 for subnetting purposes, and then the remaining question marks or the black values would be the host portion, and these are the 16 host IPs in a particular subnet. So first subnet would be 192.168, that is the 2.128, that is the first subnet, and then the network address is 128 and broadcast address is 144, and we have around IP available for endpoints from 129 to 142, and in the second subnet it would start from 144 and it would go till 159, and 159 would be the broadcast address and 144 would be the network address, and third would be the 160 subnet, and it would go till 175. So 175 would be the broadcast address, and in the fourth subnet it would start from 176 and it would go till 191, and 191 would be the broadcast address and 176 would be the network address. So this was all from my side. Please stay connected to my channel for similar videos. Thank you.